Let me go do this real quick, I guess. You guys could start figuring out what it is that you wanted to talk about for the starters while I'm going and just moving blank copies onto our page today. Oh, I said I was going to start with talking about the test format, didn't I? Mr. Kulik, don't be a liar. Okay. I try really hard not to be. Okay. So test format. The test here is 7 questions, but they all have multiple parts, so it's really like, I don't know, like 15 or 20 questions or whatever. Basically, you have 2 questions that are kind of section 2 questions where I'm going to ask you to find the side lengths inside of figures. You have 2 questions that are like finding maybe side lengths and angles inside of figures. You got like 2 surface area volume kind of questions, and you got like 1 big dog like multi-parter, kind of like the last 3 questions or so from the homework set that were like a little bit longer, more involved than your typical ones. But that's basically the test format. Reminder again that if you look at the last page of the review guide, that's the equation sheet that you're going to be getting for the test. So I think most everything that you need on for the test is on there, but you know, like if you're looking through that and you're like, boy, I used blah, blah, blah formula a couple of times and that's not on there, then, you know, it's on you to kind of remember those. But I think it's pretty comprehensive in terms of things that you would reasonably need to use. Does that feel okay, test format-y? The last thing I would say is that I would, if you haven't done the whole problem set or done the review, I would encourage you to make sure you spend some time with that, as the same kinds of tricks on some of these problems are the same kinds of tricks that'll pop up on the test. You may see like very similar situations to things you saw in the problem set or the review guide or whatever. Okay. Let's do questions. Who wants to go first? Anybody got anything that they were confused on? Paul? Certainly. Okay, so 6 is here. It says liquid is poured into a spherical, container to a height h. The radius of the sphere is 22 centimeters. The top of the liquid is a circle with radius 10 centimeters. Figure out that height. So the trick here, Paul, is that that the radius of the sphere is 22. And there's lots of radii we can draw here. So anything from the center of the sphere, which I'm drawing here in red, to the surface of the sphere is a radius. So like that's 22. So what we're going to be forced to do is figure out this side, which is x, because I know h is just 22 plus x. Okay? The hard one to see is that this is also a radii. And once I have that, there's my right triangle to work out x, and it's, you got it from there, I would think, right? So that's the trick on that one, is just drawing in those other radii. And some of them are kind of sneaky to see where those are at. But once you've seen the trick, it's not so bad. You feel cool?
Yep, thank you.
Yeah, no problem. Who's next? Amanda. 12? Sure. And you guys are okay with like me kind of doing all but the finish of this, right? Just kind of like setting things up, and then it's like, okay, I can Pythagorean theorem this, or like type it in my calculator just so that I don't spend, you know, an hour doing questions and we're out of time for the homework quiz or whatever. Okay. So here on 12, Amanda, you could do this in any order. You don't need to do part A in order to do part B, just as an aside. So I'm going to do them in the same order they are here, though, but they're unrelated, really, questions. So to do part A, what I'm going to do is I'm going to say, okay, I'm going to look at this triangle here, and then I'm going to look at this triangle here. And what I notice here is that x is going to equal the difference in an angle DAB and angle CAB. You cool with that? And I like doing it that way because both those two triangles, the blue one and the green one that I just drew in, were right triangles. So I can just do right triangle trig to figure out those angle measures. So I know side AB is 40. I know side CB is 30 because I told that C was the midpoint. So DAB is just going to be the tan inverse of opposite over adjacent. And then tan inverse here of opposite over adjacent. So that's that. Feel okay there? To do part Y, or I'm sorry, to do part B to get angle Y, I'm going to notice that angle Y forms a linear pair with angle ACB. So Y is just going to be 180. Oh, if my pen was still working. One moment. Oh, maybe that was, there we go. So ACB. And again, that's part of a right triangle, so I can just do right triangle trig on that. So tan inverse of opposite over adjacent. Or you could have borrowed, you already found angle CAB, so you could have done 90 minus that to get angle ACB, depending on which one you did first. You know what I mean? Yeah, no problem. And again, you could have done these several different ways. You could have done non-right triangle trig on these things and used like the law of sines or law of cosines to do these problems. Some of you might have done that, and that's fine. Totally fine. You should still get the same answers. I like doing this because it was all right triangle stuff, and it was, or like little geometry things where it was all pretty easy. There was no like, oops, I accidentally stumbled into an SSA situation or an ambiguous case thing, and like, oh no, you know, like can avoid all the worries there. Amanda, you feel good?
Yeah.
Okay. Tommy, did I see your hand?
Yeah, 29.
29? Sure. And you guys are good again with the setups and just kind of working through these. If you want the actual answer, I can look those up for you too and just tell you the answer along the way. But if you're good with just the setups, I'm good with that too. Okay. So it says a garden shed has a cross section in the form of a pentagon with the following lengths, yada, yada, yada. Find the volume of the shed, okay, and then work out the total surface area of the roof, okay. So the volume for the shed, what I'm going to do is I'm going to just do the volume of the rectangular prism on the bottom plus the volume of the triangular prism up top. So the rectangular prism is just length times width times height. And then the triangular prism is going to be the area of the base, which maybe isn't that clear, times the height, which is still 5. So there's a couple of ways you could do this. Let's write that as B. So we know that this is 2.3. We know this is 1.6 and this is 1.6. So I could use Heron's formula to calculate the area of that triangle since I know the 3 side lengths. That would be appropriate to do here. So you could do it that way. Alternatively, since this is an isosceles triangle, if you drop a perpendicular here, that is going to bisect that side. And then you can use a Pythagorean theorem to figure out the height of the triangle and just do 1/2 base times height. That's also appropriate to do in that case. Does that make sense, Tommy?
Yeah.
Yeah, no problem. And then part B is really straightforward because the roof is just like this piece on either side, so just 2 rectangles. Like the roof is just the part that would have the shingles on it. So like in your most basic house, which is like a rectangle with a triangle on top, it's basically just 2 times that rectangle. So 2 times, let's see, that's 1.6 by 5. So that's it. If you wanted the surface area of the barn or something, that's a horse of a different color. That's a little bit more complicated. But to be honest with you, I think that it's just a bunch of rectangles in the area of that triangle, which we just talked about how to find, which would have been the trickiest piece. But Heron's formula is like an example of something that's like, when would I really want to use this? These are the situations where like, oh yeah, that's actually quite helpful here. Aiden?
Could you do 30, but could you show the answer since it's even?
Yeah, I can tell you the answer. Okay. So we're packing tennis balls into a cylinder, right? Find the dimensions of that cylinder if 4 balls are fit into there. Well, the radius of the cylinder needs to be really the same as the radius of the ball, right? And if we got 4 balls stacked up in there, the height of that cylinder is going to be 4 times the diameter of the ball, so really just 8 times 3.2, whatever that comes out to be, 25.6, I guess. Does that feel okay? And then it says find the volume of the unoccupied space. So that's just going to be the volume of the cylinder minus the volume, 4 volume of the spheres. So the volume of the cylinder is just pi r squared times the height. And then the volume of the sphere, 4 times 4/3 pi r cubed. When you do that, I think I get 274.52 cubic centimeters.
It was just an even, so I didn't know.
Yeah, totally fair. Yeah, it's not a big deal. You can ask what the answer is supposed to be. Yeah.
For the height, why is it 8, not 4?
Well, because it's 4 diameters. So it's like 4 times 2 times. Right? Because this is diameter. We write that way too is okay. Good question. I said it real quick and I wrote it down, and maybe that, if you're writing, it's hard to do listen and hear it, or listen, yeah, listen and hear. Listen and write at the same time. Sometimes I have the same problem. Who's next? Happy to do more. Yeah.
Number 19.
Sure. Uh, 19. Okay. Says the following is a diagram, shows a hemispherical bowl, radius of 15 centimeters, liquid poured into a height of 8 centimeters, circular surface area, blah, 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 whatever. For the bowl, calculate the volume. And then the surface area, note that it's an open top, so that, okay. Well, the water makes no difference in this problem, right? This looks like Mr. Kulik just recycled the situation from another problem and asked you to do something different with it. Would have been a more interesting question is like how much air or how much volume is left in the bowl, but I didn't ask that. That would have been the more interesting volume question. But to do the volume, it's just basically going to be half of the sphere okay. Cool with that. And the surface area, what it's saying here is that if this was a solid, like you had like a solid circular rock and you cut it in half, the top would still be a surface, right? This is saying that no, it's open, it's like a bowl, so we're not going to count the inside as a surface. It only wants, like, if you're going to paint the outside of your bowl or whatever. So basically it's just half the surface area of the sphere, which I think is 4 pi r squared. Let me double check that real quick. I always confuse that whether it's 3 or 4. Nope, 4. Or at least I guess I didn't, I've second guessed myself. You ever second guess yourself? Happened to me. But that's it, you know. Confusing question because Mr. Gulick didn't, I don't know. Had a bunch of information that didn't matter. Almost like he was in the middle of doing it, got confused at what he was really wanted to ask about, and then wrote a different question. I don't even know that I wrote this question. Somebody did, though. Probably me. Next. Yeah, Lexi. 8. Okay. So here we have a cone with a slant height is 60 and the radius is 20. We want the perpendicular height of the cone. So that's this side here. So that's just using the Pythagorean theorem, right? So I have my triangle right here. So h is the square root of 60 squared minus 20 squared. I did some algebra with the Pythagorean theorem to get there. You cool, though? Okay. And then for part B, it asks for the angle AVB. So what I'm going to do is I'm going to just observe that because this is an isosceles triangle, those two angles are congruent. So what I'm going to do is just say that angle AVB is equal to 2 times angle OVB. And angle OVB is inside of a right triangle, so I can just do like, let's use sine inverse of opposite over hypotenuse. Now do it. Is that okay? Again, the fact that I know that this is an isosceles triangle because the slant height on says it's a right cone, so the slant heights have to be the same. That saves me a lot of annoying geometry, and it makes it like, oh, cool, just splits it in halfsies. But again, like, I want to make sure that I explain why I'm able to do that, right? That the why is super important there. It'll often be the case that that's the case, but Grace. Yeah, sure, go ahead. Anybody else? Questions from the sets or the homework or the reviews or whatever? Okie dokie. So we'll do the homework quiz, and when you're finished, you can just spend your time working on the problem set or the review or whatever is kind of the highest priority item for you right now. Cool? All right.
Open a Google Doc.